Problems on our practice test module 1. Notice in this problem number 10 you have a power to a power, so that's z to the second power raised to the third power. You know the rule, you multiply those together, so it gives you z to the sixth power, and there's nothing else we can do on that one. For our next problem number 11, we're going to use the product of conjugates to multiply. The fact is, you don't have to know that that's the product of conjugates. You could simply be told to simplify or multiply the polynomials together. We're going to multiply 8m times 8m. Now we know 8 times 8 is 64, and m times m is m squared. Now if you don't see that, you could say 8m times 8m. Okay, and remember we're going to use the FOIL method here. So first, outer, inner, last. So first times first, 8m squared is 64m squared. 8m times 2n. Again, you can write plus 8m times 2n, or go ahead and simplify it, and 8 times 2 is 16, and m times n is mn. Okay, why is it positive? Because positive times positive is a positive. So that was outers. Now we're going to do the inner terms together. So that's the 2n times the 8m. Now notice this is a positive times a positive, so I'm going to get a negative. And you can write it down, 2n times 8m. Or you could go ahead and multiply it in your head, so it would be negative 16. Now you could write these variables as n times m, but since the first time we wrote them as m times n, I'm going to be consistent and write that in the same order. So minus 16 mn, and then we're going to multiply our last terms together. So negative 2n times positive 2n. Now a negative times a positive is a negative, and then you could write that as 2n times 2n, or you could go ahead and say, well, 2 times 2 is 4, n times n is n to the second power. Now here's what happens when you have conjugates. These middle terms cancel out every time you multiply conjugates together. So some people skip that step and just multiply the first two together and the last two together and know that it's minus. But I think it's good practice to go ahead and do all of the FOIL method when you do these binomial conjugates. And then just cancel them out. That way you're applying a method that works for every type of multiplying binomials together other than just the conjugates. Problem number 12, you see we have w to the 19th divided by w to the 3rd. And when you divide the same variable, you simply subtract the exponents. It's always larger minus smaller, so 19 minus 3. And leave the answer where the larger one is. So that's going to be in a numerator. So you have w to the 19 minus 3, which is just w to the 16th. Again, what's left in the denominator, really, that's just a 1. And then w 16th divided by 1 is just w to the 16th. So here's the problem that most students need help with on the first test, or practicing for the first test. And this says divide. We know it's divide for two reasons. It says divide, and there's the division symbol in the middle. And this is long division. Now, one of the problems is distinguishing long division problems from non-long division problems. Now, we know this is long division because of the minus, and it could have been a plus, inside the divisor. So if this was just 3xy or x or 2x, no addition or subtraction, then you could simply split this up into fractions. But when you have addition and subtraction, you are required to do long division until we learn any other methods. Now, the x minus 1 is your divisor. It goes in front of the division bar. X to the 3rd minus 6x plus 10 is your dividend, and it goes underneath the division bar. Now, a couple of things I need you to know. The dividend must be in descending powers order. What does that mean? The highest exponent comes first, the next highest exponent comes next, the next highest exponent, and all the way down. And if you're missing an exponent power, you must list it with a dummy variable like a 0x. Okay, so check this out. X to the 3rd must come first. then minus 6x squared. But notice there is no x to the first term. It goes straight to 10 after that. So you have to put plus 0x and then finally plus 10 at the end. Now let's get ready for our next step, which is the division step. Okay, and you ask yourself, what do you multiply x by to make it an x to the third? Notice I'm not worrying about the minus 1 for the moment. I'm not worried about these other three terms for the moment, just the first guy in line and the first guy in line. So what do I multiply x by to make it an x to the third? Well, that's x squared, right? So I just put my x squared in the quotient area above my x squared term. Now I use the distributive property. X squared times x is x to the third, and x squared times negative 1 is negative x squared. So that's where you pick up the minus 1, is when you use the distributive property. Now you change your signs. So positive x to the third, I make it negative. Negative x squared, I make it positive. Why do we change the signs? Because it's easier than subtracting. Okay, so when I subtract, which is my next step, x to the third and negative x to the third, they cancel out. And I'm really adding x to the third plus a negative x to the third. Let's add again. Negative 6x squared plus x squared. It's going to give me negative 5x squared, and I bring down my remaining terms. Now something's very important in the steps we just did. Notice your like terms line up. X to the third is under x to the third. X squared is under x squared. That absolutely must happen. There's no other way around it. So let's keep going. And once again, I'm doing this first step. What do I multiply x by to turn it into a negative 5x squared? Well, it's a negative 5x that you need, okay? Now, I've already handled the x squared. Don't go back to that. I'm just looking at this brand new negative 5x that I put up here. Negative 5x times x is negative 5x squared. Negative 5x times negative 1, negative times negative is positive, plus 5x. Now look, once again, your like terms line up, right? If they don't line up, you're doing something wrong. Here's what's really important. Remember how we put that 0x in at the very beginning because we didn't have one? If that 0x wasn't there, the 10 would be where it is, and my like terms wouldn't line up. I would have a 5x lined up underneath the 10, and those are not like terms. I can't do that. So you must line up your like terms. I'm at the change your signs spot. Negative 5x squared turns positive, plus 5x turns negative. Remember, I add down. So a negative 5x squared plus 5x squared cancels. I have a 0x minus 5x. Okay, or 0x plus a negative 5x, that's negative 5x, and I bring down my plus 10. Notice when I bring a term down, it doesn't change signs. Now, one more time of this first step situation. I'm asking myself, what do I multiply this x out here times to turn it into a negative 5x? And that's going to be negative 5. Again, the multiplication step. Negative 5 times x is negative 5x. Negative 5 times negative 1 is plus 5. Negative times negative is positive. Don't forget that last step to run through and change your signs. Turns positive, this plus turns minus. Negative 5x plus 5x cancels. And you have 10 plus a negative 5, which gives us a remainder of 5. Now, how do you write in your answer? Your answer is always quotient plus remainder in the numerator divided by the divisor in the denominator. Okay, so our quotient is x squared minus 5x minus 5 plus the remainder, which happens to be a positive 5, so I just put a plus 5 up there. Our divisor is x minus 1, and that is our final answer. Next problem, we're converting decimal form, or we could call that standard form. Oh, no, I'm sorry. This is in scientific notation. I changed my scientific notation to standard form. Now, this is a big number. How do I know this is a big number? Because it's 10 to the positive 5. Whenever you have a positive exponent, that means this number over here is a big number. How do I make it bigger? Well, let's move that decimal over to the left, right? How many places? 5 places. So, look, if I move it from here to here, that's already 3 places, which means I need to add 2 more zeros to make it 5 places. So my number is going to be 2, 6, 3, 4. Again, that's already 3 places. 4, 5 places. That's my number, and that number is 263,000. So again, we count. That's 1, 2, 3, but I need 2 more zeros to get the 4 or 5 in there, and that's 5 places to the right. This is a big number. Had that been -5, I would have moved the decimal in the other direction to make this a small decimal number. Next problem, I have a fraction raised to a power. How do I do that? Listen, anytime you have a fraction raised to a power, that 6 exponent, or whatever the exponent is, applies to both the numerator and the denominator. So I could write this as w to the 6th divided by 2 to the 6th. Now if I was just to simplify that, I can take it one more step because I can evaluate 2 to the 6th. So that's w to the 6th divided by 2 to the 6th now is 2 times 2 times 2 times 2 times 2 times 2. That's 6 times. 2 times 2 is 4. 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is finally 64. Or you can just type that in your calculator, 2 to the 6, and it'll tell you that's 64. Alright, so we have 7 to the 10th times 7 to the 11th. Now, y'all, this is no different than x to the 10th times x to the 11th. Y'all know what to do. When you multiply the bases, which is your variables down there, you add these exponents together. So that's x to the 21 power. Well, when there's a number instead of an x, you don't do anything different. So this is going to be 7 to the 21 power. Now, what mistake might people make? A lot of people tell me that 7 times 7 is 49 to the 21 power. You don't do that because you're handling multiplying the bases together when you add those exponents. Okay? So you don't do both of them. You don't say 7 times 7 is 49 and 10 plus 11 is 21. You only keep the common base, just like we kept this x right over here. You keep the 7. All right, let's take a look at this problem. This problem is super confusing to lots of students. Now, this is all multiplication. Okay, so there's no distributive property, no FOIL method, nothing like that. You're just multiplying things together that match each other. Now, one thing I want you to notice is look outside the parentheses. Say right here, notice there's no exponent there. Notice right here, there's no exponent there. So I'm not having to take this exponent into each one of these factors. I'm really, y'all, just multiplying things that match together. Okay, so I could rewrite this and say -2 times 8 and group together the coefficients or the numbers. I can say c to the 5th times c to the 4th and sit those next to each other. I could say d to the -7 times d to the -2 and set those next to each other. Right? I can do that. So I'm just grouping. I'm just moving things around because when you multiply, the order you multiply in doesn't matter. Now, we know -2 times 8 is -16. When I multiply c to the 5th times c to the 4th, you know what to do. You add those exponents together. That's going to be c to the 9th. Right over here, when I multiply d to the -7 times d to the -2, once again, I add those together. That's going to be d to the -9. You know, -7 plus -2 is -9. Now, here's the deal. I'm not supposed to leave it like that because I'm not supposed to leave negative exponents in my answer. You remember what a negative exponent means. That means this whole guy right here goes in a denominator, and that exponent changes to positive. So I have -16 c to the 9th, and I now have d to the +9 in the denominator. So that's a suitable final answer. Another thing you could do is move that negative right in the front into in front of the whole fraction. So 16c to the 9th over d to the 9th. Both of those answers are appropriate. You don't want to leave negatives in the denominator, like this negative number right here in the denominator. You don't want to do that, okay? And you don't want to ever leave negative exponents. So that's completely simplified. Either one's appropriate. All right, problem 18, it says find the quotient. What does that mean? It means we're dividing, but you can tell we're dividing because you have a fraction. Anytime you have a fraction, you're dividing. Do I need long division? No, absolutely not. You don't have any addition or subtraction in the denominator. Do I split this up into separate fractions? Well, no, because you don't have any addition or subtraction in the numerator. This is one single fraction. You simplify the number part. You simplify the r's. And you simplify the s's, almost like it's three separate problems. Now, when you simplify the number part, okay, negative divided by negative is a positive. I know everybody knows that. And then 40 over 56. Now, what number divides it? You're just reducing a fraction to lowest terms, right? What number divides into both 40 and 56? We know it's 8, right? 8 goes into 40 5 times. 8 divides into 56 7 times. So negative 40 divided by negative 56 reduces to 5/7 in fraction form. Now let's move to the r's. I have an r to the 12th on top, an r to the 8th on the bottom. Remember, the rule is when you divide bases, you subtract exponents. 12 minus 8 is 4, but notice the 12 is the bigger. It goes in the numerator, so you have r to the 4th. As opposed to the s's, the bigger one is in the denominator. So I do 10 minus 7 is 3. That means s to the 3rd belongs in the denominator, and that's as simple as that gets. I should say as simplified as it gets. I'm not saying it's a simple problem. I'm just saying this is completely simplified. Okay, problem 19, we have multiplication. It says multiply. I could easily say simplify. And again, this is just all multiplication. There's no addition, subtraction, so there's no distributive property needed, no FOIL method, no first, outer, inner, last, nothing like that. You're just, excuse me, multiplying the number part times the number part, and then the a's times the a's, and the b's times the b's. That's it. That's all you're doing. If you would like to group these together, you could do that. In other words, negative 6 times 2, and then b to the 6th times b to the 1st, that's a 1 right there, and then you could do, there's all that's left is an a to the 5th at the end, right? Just make sure you don't leave anything out if you reorganize like that. Most of you would just go, hey, negative 6 times 2 is negative 12, b to the 6th times b to the 1st is b to the 7th, and then a to the 5th is dragging on. Now, I'm perfectly happy with that answer right there, but let me tell you, if you were to type that in Newton Alta, probably put the A before the B only because, you know, they have a limited number of correct answers they type in there. So maybe they always put these things in alphabetical order. And there you go. So negative 12, A to the 5th, B to the 7th. Something else I want you to notice is there was no exponent outside the parentheses here. So I didn't have to simplify each one of these sets of parentheses first. I went ahead and started multiplying everything together. All right, now here's one of everybody's favorites, number 20. Now, notice we have a set of parentheses raised to a power. Okay, so that means I've got to handle that power up there. One option, and it's not my favorite option, one option is to apply the negative 3 to everything inside. So you could say c to the 5th to the negative 3 power and multiply those exponents together, and d to the 5th to the negative 3 power and multiply those exponents together. But it might be easier to handle that negative exponent. Now we have a rule that says when we have a fraction raised to a negative power, we flip the fraction. So that's the first thing I'm going to do is flip that fraction upside down, and it's only because a negative exponent, okay? If you have a negative exponent on the outside of a fraction, you want to flip it. So this, what about this negative in the front? It stays. Okay, it's just sitting there. Now, so now this is going to be d to the 5th over c to the 5th. And now that's to the positive 3 power. What am I going to do now? I'm going to apply that 3 to both of those. So that's going to equal to negative, and that's going to be d to the 5th to the 3rd over c to the 5th to the 3rd. If you were thinking, why'd she write that? Isn't that just d to the 15th? Sure is. Okay, d to the 15th over c to the 15th. This negative out front, notice it didn't change anything that we're doing. It's just negative the whole way through. It just carried along. It wasn't inside the parentheses to even be concerned with. So again, we flipped our fraction because of the negative exponent. If there was a positive 3 there, I wouldn't have flipped anything. I would have just went ahead and multiplied exponent times exponent together. Directions on this one's important. This is not a simplified problem. This is the only problem that we have in this list that couldn't get away with just saying simplify. Determine the degree of the polynomial. What is the degree? Okay, remember the degree is the variable power that shows up. Now, what I'm going to do for this problem is show you a couple other problems just in case they say degree, because this kind of oversimplifies things. But if I gave you the problem, say 5x to the 4th, y, z to the 3rd, okay? That's a monomial, it's just one term, and the degree of that thing is you add all those exponents together. So that's 4 plus 1 plus 3, right? Because there's always an implied 1 there. That thing is a degree 8. All right? Well, what about this? If I gave you x to the 4th plus 3xy to the 3rd plus 4xy minus 7. Okay, now that's a polynomial. It's got 1, 2, 3, 4 terms. To find the degree of it, you would have to find the degree of each one of those terms. Okay, so the degree of this one all by itself is 4. The degree of this one is also 4 because there's an implied 1 right there. I add those together to get 4. The degree of this term is 2 because this one and this one. What's the degree of that? Well, there's no x at all, right? So that's a degree 0. Now, when you have a polynomial that has more than one term, therefore more than one degree, you take the highest of all those numbers. So this is degree 4. Okay, so that's a degree 4. Which brings me back to our original problem. There is no variable part here, so this thing is a degree 0. That's all that we've got there, degree 0. All right, and our last problem on the list, problem number 22. Is that right? 21, 22. Okay, so we have 22 problems. And this one's a big one because you're adding and subtracting 3 separate polynomials. Okay, this is not multiplication. There is no first, outer, inner, last because of the big minus signs in the middle. Okay, so this is subtraction, this is addition. What do I do? Well, my advice is first to remove the parentheses. Now, when you have a negative in front of parentheses, it's going to change the signs. So this negative 12pq squared is going to turn positive. This negative 11q to the 3rd is going to turn positive. But it only applies to the set of parentheses directly after it. This plus over here doesn't change anything. These stay exactly as they are. So my advice is to write all this down without the parentheses. So the first set is negative 11p to the 3rd minus p squared q. And it's like I'm distributing this minus sign. So this negative and this negative make that plus 12p q squared. And this negative makes this negative a plus 11q to the 3rd. Now again, plus here, but plus a negative is just minus. So this is minus 10p squared q. Again, notice the sign of the 10 did not change. It's negative here, negative there. This stays the same as well, negative pq squared. So pay attention to when we changed and when we didn't. Only when there's a negative in front of the parentheses does it change the signs after it. These stayed the same and these stayed the same. Now our next big issue is writing down like terms. Okay, so p to the 3rd. So this, all these are separate terms. Terms are separated by addition and subtraction. And you can only combine together terms that match. Okay, match exactly, exponents and all. So p to the 3rd does not show up again in here, okay? All right, so I'm going to move it down, 11p to the 3rd. Does p squared q show up again? Now, I'm hoping you say, yes, it does, and that you see it. So here is a p squared q, and the minus 10 is also a p squared q. If you want, you could group those together. So minus p squared q minus 10 p squared q. We'll handle that in a minute. Now, I'm looking at a pq squared, which is not the same thing as p squared q, right? Here the p is squared, here the q is squared. So is there another pq squared? And I'm hoping you're telling me, yes, there is at the end, right? So I'm going to group those together. Plus 12pq squared minus 10pq squared. Okay? And then What's not underlined, we've already listed that one, the 11q to the third. All right? So I'm going to write that at the very end. It doesn't have a like term, 11q to the third. Now, what I want to do is combine my like terms. So again, we talked about a negative 11p to the third doesn't have a like term, but these can be combined together. Now, another thing I need to let you know is when variables don't have a number in front, that's an implied 1, right? So when I have negative 1 added to a negative 10, notice I said added in between because you can always add and take the signs as positive negative rather than addition and subtraction. So a negative 1 added to a negative 10 is a negative 11 p squared q. And then when I move on to the pq squares, I've got 12 plus a negative 10 is going to be plus 2pq squared. And then at the very end of that line, I have plus 11q to the third. Now, certainly don't have to write that in all those different colors. My final answer, just recopy this, is negative 11p to the third minus 11p squared q, that's a q, plus 2pq squared plus 11q to the third. Hope this helps you out. If you have any questions about these problems, please send me an email and let me know so we can get any issues you have straightened out. Have a wonderful day.